Hello guys, welcome back. This is Krishna and welcome to AI Martian. So we were talking about deep learning series. So in deep learning, I was talking about loss functions. In the previous video, I have taught you about binary cross entropy. Now in this video, I will talk about categorical cross entropy. It is just modified form of binary cross entropy. In binary cross entropy, we have to consider one thing, that is the classes in the data set should be two, not more than that. Okay. But if you have more than two classes in your data set, then you can use categorical cross entropy. It simply helps us to calculate the losses of our actual target and predicted target. Okay. So there are some formula behind it. I will show you each and everything. So let's go to Google Colab sheet and we will implement it. But here I would like to tell you one more thing. I'm not going to show you these things in a algorithm, not in this video, but in upcoming video I will show you for sure, because it worked with more than two classes. So I did not introduce any kind of model so far in front of you guys. So I would just give you the theoretical representation of this, and once I will train a model of more than three classes, I will show you how to implement it. But don't worry, I will show you how can you use when you work with multiple classes. Okay, so let's go to Google Colab sheet. So here we are guys on the sheet. Let me show you. So this is that categorical cross entropy about which I'm going to talk in this video. So I just want to show you the explanation, like how it works. So see, let's say I have a data set which have three type of classes. Okay, let's say I have a 150 samples of iris dataset. If you guys don't know what is the iris dataset, I already explained iris dataset in my machine learning video. Of course, that machine learning video in Hindi. So please go through it. If you don't know, I will also explain you here. But I would request you to first go to machine learning playlist, so you guys will get better understanding of like what is iris dataset, how machine learning work, and why people move toward deep learning. Okay. So it's a recommendation. It's totally up to you guys. Now there are 150 samples in iris dataset. So what was that? 50 samples. I'm just mentioning here 50. 50 means 50 samples. Okay. So 50 samples belongs to iris virginica. 50 sample belongs to versicolor. Sorry for my spelling mistakes, guys. You have to go through. And 50 samples belongs to Sitosa. Some sort of spelling were there. So there were three kind of iris plant. Some scientist or researcher created a data sample or data set, you can say, which contain 150 samples. Okay, so 150 samples is a combination of these three type of flowers. Okay, iris flowers. These all belongs to iris community. Iris is a kind of flower, and these all three samples or three different varieties of the same iris plant. Okay, iris flower. Okay, so this is let's say our data set, and in this data set I have more than two classes. The first one is a virginica, then versicolor, then setosa, right? So I just need to calculate loss. See, I'm talking about how to calculate loss and why loss is useful. Okay, I will tell you later on. Okay, so to just for now, to get a better model, so we can ask after training that model like any kind of question, any kind of sample. If I will pass my model, let's say this is my model. Okay, if this model get trained, okay, on multiple or more than two classes kind of data set. So in that case, what I have to implement to train this model, I have to implement this categorical cross entropy while training this model, okay? Because there were more than 2 classes in the data set, okay? I mentioned here multiple classes or more than 2 classes, okay? In the data set, if this is happening, okay, while training any model where more than 2 classes we have, and that's belong to classification because there are classes. So in that case, you guys have to implement categorical cross entropy. No need to think much, okay? It's a very good loss function, okay? So it will help you out to get the better model, okay? For deployment or to get any kind of expected output. So, I'm coming on the same data set once again. So let's say I have a data set where I have 3 classes: versicolor, Virginica, versicolor, and Setosa, right? So to train this model using deep learning, because we are learning about deep learning, which is the subdivision of machine learning, AI also. So deep learning, in deep learning, when we create neural network, which I have already shown you above, okay? Let me show you once again. So this is my neural network. See, this is my neural network, okay? This is my neural network, and I use here loss, okay? So let's say if I have more than 3 classes in my data set, I will simply use categorical cross entropy at this marked point, okay? So if you will mention that categorical cross entropy, so my model will able to calculate the best losses, okay, and the model will learn quicker, okay, and give us a better result. So here what I have to do here, I have to mention categorical cross entropy, okay? You have to mention categorical cross entropy. So categorical cross entropy simply help us to get losses when we have more than 3 classes. This is the only thing you guys have to remember in this video, okay? But the guys who are interested to know like what is the mathematical concept behind it, I can also explain that, okay? And I'm going to explain those part. So I'm just scrolling it down because I need a white background for this. I have to write a lot of things on the board. Okay, so see what happened. Think about it. So let's say I have 3 classes in the data set. So for each sample means, suppose this is my data set. Okay, this is my data set, iris data set, okay, where I have 150 samples. So for now, I'm just assuming there are only 4 samples: first sample, second sample, third sample, and fourth sample, okay? And its target is like Setosa, versicolor, and virginica, something like that, okay? And again Setosa. So if I will pull this sample, this is called one sample, okay? Sample, okay? This is not a data set, this is a sample because I pull one value, okay? One row, okay? So that is what sample. So in that sample, let's say this is Setosa, I mentioned it by S. So Setosa is not represented by S. We have to do one-hot encoding, and I already taught you about one-hot encoding in the earlier videos. So please go through it. One-hot encoding you will understand, okay? So what is one-hot encoding? So suppose in this data set we have 3 class. So in this sample for Setosa and for every target, okay, for every target of each sample, I have to create 1D array, and there I have like 3 kind of classes, okay? So Setosa, versicolor, and virginica, let's say. I'm mentioning virginica by VER, okay? So let's say this first sample belongs to Sitosa. So Sitosa will be something like this: 1 versicolor. It is not versicolor, so of course 0. It is not virginica, so of course it will be 0. So similarly, all the values. Similarly, if I will go for the second sample, okay. So in second sample, this second sample doesn't belongs to Sitosa, right? So I will mention here 0, and for versicolor I will mention 1, and for virginica I will mention 0. For third sample, I will mention it is not Setosa, of course, it is not versicolor, but it is virginica, right? And for fourth sample, what I have to do, I have to mention like 1, 0, 0, because this last sample belongs to Setosa. So this is what? This is one hot encoding. So this one hot encoding I already taught you in the same playlist. So please go in my one hot encoding video, okay? That's already there with the title. So if you'll go in this deep learning playlist, you will find that one hot encoding concept there. Now this one hot encoding gives us each and every class, okay, by representing some number. So 1 means that particular sample, means the first sample belongs to Sitosa. That's why there here is 1 and rest are 0, okay? So loss function also do something like this, but before that our model calculate probability, okay? So I just want to explain it once again. Let me use different marker. So I'm just picking this sample, okay? So let's say I am writing here 1 0 0, okay? So once we train a model, we have some activation function. So at outermost layer, let's say I have softmax. What I have? Softmax, because I already told you in activation function concept, softmax always use at outer layer, because there we calculate probability of each classes if there is more than 2 classes, okay? Again, more than 2 classes. Softmax always use at outer layer where we have more than 2 classes. Keep these things in mind. I also remember these stuff in the softmax or activation function videos. So softmax simply do what? Softmax calculate the probability of the possibility of this first like it belongs to Setosa, right? So what is the possibility? The sample which I have given to my model, I pass this sample to my model, okay? This is my model, and my model is already trained on this data, okay? So this is my actual y, okay, actual target of first sample, and this is my predicted target, okay, of first sample. So predicted target would be in the form of probability. So whatever value will come here, let's say 0.8 and 0.1 and 0.1, okay? So if you will add them, you will get the probability, which is 1, which is also known as 100. So now first this model calculate the probability, and after that we have to calculate loss. So I'm just cleaning this window, okay? Let me clean this. Okay, so now I have to explain about categorical cross entropy mathematical formula. So categorical cross entropy, categorical cross entropy. Okay, how it works? So let's say this is the formula of categorical cross entropy. I'm just denoting L just to show the loss. Okay, so loss short form is L, I'm saying, minus summation of I to the 1 up to n, and here I have yi, which is again multiplied to log yi cap. Okay, this is I. Now what is y? Y is this. Yi is the actual value which is given in our data sample, and yi cap is the predicted value, or you can say probability, predicted probability, okay, of each classes. Like what is the probability of the first sample, what is the probability of second sample, and what is the probability of third sample. So whatever probability is high, that particular sample belongs to that class. So this is 0.8. This is the maximum probability, and it is on 0th index. So it is on 0th index. If you'll go here as well, so it is also on 0th index. This is belongs to first class in the actual data set. But after getting prediction from the model, it is saying like 0.8%. My model is sure that it belongs to first class, and that's why it is mentioning something like this. So the maximum value, it is showing us 0.8. Okay, so what are the laws there? So if you will see this, this is 1, that means this is 100% sure. In our actual data set, it is given 1, that means 100% that the sample belongs to first class. Okay, but in our predicted sample, I'm getting 0.8%. My model is sure that this particular sample belongs to first class. My model is 0.8% sure. It is also confused a little bit, like 0.1% it belongs to second class, or 0.1% belongs to third class. There is something like that. But in our actual data set, there is given like it belongs to first class, which is Sitosa. So my model is what? Showing some losses here. Okay, because it is not showing me 100%. It is not showing me 100%. That means 1. Okay, it is showing me 0.8. Okay, so that's why there are some losses. And to calculate those loss, what we have this formula, and this formula we called categorical cross entropy, which we also implement in our model, okay, while training it. So the loss is I will say, what is this? Yi is what? Y is the actual value. So this is the first value. I will mention here 1. Okay, after that I will again put a bracket, because see, minus is at the outermost. Okay, so I have to keep it away, like something like this. I can mention here a big bracket. Okay, and before big bracket I have to mention minus. Okay, because that is also here we have given in the formula. Okay, now I have to simply mention a bracket. In bracket I have to mention the first value of the actual value, that is 1, multiply to log. This is log. Okay, 1 multiply to this log yi cap. So yi is what? This is yi. This is the first value, right? So 0.8. See, I is equal to 1. Okay, it will start from 1 and go up to n, means whatever sample. Here I have 1, 2, 3 samples, right? So I will start from 1. That's why I'm getting 0.8. Again, plus I will mention here the second value, which is yi. This time I value will become 2. So on second index, in the actual value yi, I have 0, and I will multiply that 0 by log of yi cap 2, which is 0.1. And again I will put a plus there, and after that I have to again change the value of I, and I value this time is 3, right? So on third index we have again 0. So I will mention here 0, 0, and multiply. I have to mention here log yi cap. So yi cap, here again I have I, so here again it will convert into 3. So yi will become this one. Yi cap will become this one, 0.1. I will mention here 0.1. Okay, once you will close this, okay, once you will close this and calculate it, it will be something like minus log 0.8, which is approximately equal to 0.223. So this is the loss. Now this is happened on each epoch, okay, because after training one epoch, the full epoch, the model calculate loss, and again it optimize it. Okay, I didn't tell you what is optimization and all. I'm still talking about the losses. Okay, so it is a step-by-step sequence. I will go step by step, so you guys will not get confused, but you have to go through the videos from start to end. Okay, so now this is how the mathematical concept work of categorical cross entropy. I would request you to please go through this video multiple time. Okay, because this is not tough. Okay, if you guys just make a note of it sequentially, it will definitely a easy concept. Okay, and if you guys get any kind of issue related to it, you just comment me. You can join me on Telegram, Instagram, WhatsApp group. Okay, you can join me everywhere. Okay, you can also put your comment in the comment section. I will definitely entertain you guys over there as well. If I will find like a lot of candidates are getting issue there, I will definitely recreate this video. So do like, share, subscribe to this channel, share with your friend, family, and let me know if you have any question. Thank you guys, thank you very much, and stay tuned.